Welcome to this explainer. Today, we're setting up a pretty fascinating bridge between two completely different worlds. On one side, we have the invisible, highly complex digital world of software tracking. And on the other, we have the incredibly massive, incredibly physical structure of the United States Navy. I know, it might sound like a strange combination at first, but I promise you, by the time we wrap up today, you'll see exactly how deeply connected they really are. So, here is the fundamental question we're tackling today. How do we maintain order in complex systems, from vast code bases to giant battleships? Whether you're a developer trying to find a tiny error buried in millions of lines of invisible code, or a naval commander trying to safely move 1,000 sailors across a massive ship, the core problem is exactly the same. You are managing chaos. You absolutely need to know where everything is, what everything is doing, and exactly how to fix it when something inevitably goes wrong. Okay, let's dive into this. Here's our clear roadmap for combining these domains today. We'll cover governing complex systems, monitoring software, and comparing observability tools. And then we'll pivot to military order and formations, securing information, and finally, career advancement.
All right, starting with Section 1, Governing Complex Systems.
For this first part, we're focusing specifically on how we keep an eye on the invisible digital world of software code. Now, when an app on your phone works perfectly, it feels a bit like magic, right? But behind the scenes, it requires intense governance. For absolute beginners, there's one vital concept you need to understand: APM, or Application Performance Monitoring. Think of this as basically a vital health check for digital applications. Just like a doctor checks your heart rate and blood pressure, APM tools track the speed, reliability, and overall health of a software application. If a website suddenly takes 10 seconds to load instead of 1, APM tools sound the alarm. Moving right along to Section 2, Monitoring Software. The daily challenge developers face is tracking down little bugs and errors before they break the whole system for the user. When a piece of code breaks, they need to fix it fast, and they need specialized tools to do it. One of the most popular is Sentry. Built with a developer-first mentality, it makes finding those bugs incredibly easy. I mean, you can drop their SDK right into your application with literally just 5 lines of code. There are no heavy agents to install, so you don't get any performance surprises. They even have this neat AI debugging agent called Seer. It acts as a code reviewer to predict and prevent errors before they ever hit production. It's all about catching the problem before the user even knows it exists.
Next up, Section 3, Comparing Observability Tools.
Now, what's really interesting about this slide is how it breaks down the differences. Because not all monitoring tools do the exact same job, a huge part of the learning curve for beginners is just figuring out which tool to use for which task. Comparing New Relic to Sentry using signals as data, we see both do APM, that general health check we talked about. However, New Relic handles infrastructure monitoring, which Sentry doesn't do. On the flip side, Sentry offers profiling and an open-source version, which New Relic lacks. So the absolutely crucial point here is understanding their different philosophies. New Relic is designed to look at the big picture health of the entire system, that full stack observability. It's the drone view. Sentry, on the other hand, zooms all the way in. It's built to give you granular, highly detailed insights into specific application errors. Actually, Sentry will literally identify the exact line of code causing an issue. 2 different tools governing the exact same complex digital space, but in entirely different ways. Let's switch gears with Section 4, Military Order and Formations. All right, now we are completely leaving the digital and jumping into the physical. Because, just like software needs meticulous tracking to prevent chaos, massive human systems need strict physical structure to function efficiently and safely. Here, you see sailors standing in a military formation at parade rest. This right here? This is what physical observability looks like. When you have hundreds or thousands of personnel, order relies on everyone knowing exactly where they belong in a formation. A commander can look at this group and instantly see if someone is missing or out of place, just like a developer looking at a clean digital dashboard. To achieve that perfect structure, the military uses a grid system, which we can easily demystify. Notice how formations are built on ranks and files. A rank is simply when people are lined up side by side. A file is when people are lined up uniformly one behind the other. If you have more than one rank, you automatically have columns or files. It's brilliant, really. It creates a perfect grid-like order out of what would otherwise just be a chaotic crowd. But how do you get that grid to move together? Well, through highly structured verbal codes. Military drill commands are fundamentally 2-step processes to ensure perfectly synchronized execution across the entire system. First is the preparatory command, like forward, which warns the system what is coming. Then comes the command of execution, like march, which tells everyone to act instantaneously. And a great little detail, no two commands begin with the same preparatory word, which totally eliminates confusion. And this brilliantly illustrates how this physical code gets incredibly granular. Turning formation requires precise footwork. On the left, facing movements require pivoting your body exactly 90 degrees on specific heels and toes. On the right, flanking movements allow a whole group to change direction simultaneously while marching. It's essentially programmed footwork. It allows human beings to maintain total order without ever bumping into each other. Moving on to Section 5, securing information. Whether you're building software or running a Navy base, structure isn't just about moving around, it's also about restricting access. Software tools must secure sensitive data, and physical organizations must do exactly the same thing. The Navy breaks down information security very clearly. First, you have classified information, which directly involves national security. To see this, you don't just need a security clearance, you also must have a strict need to know for your specific job. On the other side, you have FOUO, or for official use only. This is privileged information, think test questions or ongoing investigations, that could be damaging if released, but isn't a strict national security risk. It's just kept safely out of the general public's hands. They actually map these information tiers directly to physical spaces, creating layered security areas. A Level 1 area is just a buffer point. A Level 2 area is where uncontrolled access risks a compromise, meaning if you don't have clearance, you must have an escort. And finally, Level 3. This is where mere entry into the room, like walking into a major command center, risks compromising the whole system. Notice how the access gets tighter and far more heavily monitored the deeper you go into the system. And our final topic, Section 6, career advancement. In any highly regulated, highly observable system, you need a safe, structured way for the individual components, meaning the people, to upgrade and move up. In the Navy, this is heavily gated by time. Notice the time in rate or TIR requirements here. These are strict chronological prerequisites. You cannot simply jump from an E4 to an E5 overnight just because you feel ready. You have to spend a minimum of 12 months at E4 gaining experience. For higher ranks, it's a mandatory 36 months. It forces much-needed stability within the complex system. But time alone isn't enough, right? The Navy uses something called the Final Multiple Score, or FMS, because moving up isn't just about passing a multiple-choice test. The FMS is a brilliant, holistic measurement of a sailor's performance and observability within the ranks. It combines written exam results with performance evaluations, time served, and awards earned. The system calculates this score to equitably select only the absolute most qualified people for the exact number of open slots. It's an incredibly thorough way to evaluate a living component of the system. Let's move to this and see how this builds, because beyond the formulas, scores, and strict manuals, the system survives through human knowledge transfer. On-the-job training, or OJT, is exactly where this happens. At the end of the day, whether you're a senior developer showing a junior coder how to use Sentry, or a petty officer showing a new recruit how to secure a hatch, real-world hands-on training is the ultimate requirement to keep the whole structure alive. And that brings us to the end of our explainer. We've journeyed from the digital debugging of software applications all the way to the strict physical grid of naval formations. But the underlying lessons, they're exactly the same. Chaos is perfectly natural, but structure, clear commands, precise monitoring, and holistic evaluation are how we conquer it. So, how will you apply these concepts of observability and structure to govern your own complex systems in your daily life? Think about it. Thank you so much for joining me today, and keep learning.